Hello, I'm Mrs. Repasky, and this is Crafting Chemistry, using materials that you might find at home to help yourself learn chemistry while we can't be at school. This lesson is about VSEPR molecular geometries, the different shapes of molecules. VSEPR stands for valence shell electron pair repulsion. So when atoms bond together and form a molecule, the electrons within those molecules repel each other. So the electrons that are in the bonds and the electrons that are in unshared pairs push away from each other. And then the atoms try and be as far apart as possible. The shapes that I'm going to go over today are a linear shape, a trigonal planar shape, the tetrahedron, trigonal pyramidal, and bent or angular. To build your molecules, you could use some things that you have at home. To make your bonds, you could use toothpicks or thin pretzel sticks. To build your atoms, you could use marshmallows, you could use grapes, chunks of potato, you could use just balled up paper. I have some other marshmallows here that are different colors. I divided them into different colors. I have some raisins, and I also have popcorn. Popcorn works out pretty well too. So the first shape is linear, and as the name indicates, the atoms just make a line. So here I have a marshmallow. I put the toothpick right through it. If I put marshmallows on either side, I happen to choose the same colors so that there's balance and symmetry. This is a linear molecule. Notice that everything lines up in a row. If you needed to know the angle of the molecule, it would be 180 degrees. This is linear. Everything lines up. The next shape is made with 3 atoms around a central atom. And as you're putting your bonds in, you want to try and make the angles 120 degrees. If you have a compass and a protractor, right, you could use those and check your angle, but usually eyeballing them gives you a pretty good result. Right? So there I just eyeballed them, and it matches pretty well to the model set that I brought home from school. I'm going to use 3 green atoms to put around this. And now this is a trigonal planar. It's trigonal for triangle. If you trace around the outside, this makes a triangle. And it's planar because it's flat. Molecules that are flat and have all the nuclei of all the atoms within the same plane are called planar. The next molecule is a tetrahedron. And this is surprisingly difficult to get right. So we'll start with 2 bonds first. And we'll put them here sticking out. Right? So if you imagine that this were a little head, here it would have 2 antennae or 2 horns. Come get you. Right? Okay. Now, here I have it this way. Now I want to turn the molecule, and when I build it, it's going to look as if I'm putting the other 2 bonds at 90 degrees at right angles to the plane of the other 2. Okay? So that when I set it up, right, it doesn't make an X. In the Lewis dot version of a tetrahedron, we draw the atom in the center, right? Like if we were drawing methane, which is CH4, we'd put the carbon in the center, and we draw a bond sticking up, a bond sticking out to the right, a bond sticking down, and a bond sticking out to the left. And we put the 4 H's around, and it would look like a plus sign. But this is decidedly not a plus sign. Where the plus sign comes from is when we're doing Lewis dots, we're trying to get the satellite view. So if you look down from above, okay, and set this on your surface, you'll notice that it doesn't stand, it tips over. Okay? Mine's not very symmetrical because it looks like there's a top to it. Okay? A tetrahedron, a true tetrahedron, is symmetric all the way around. Now, if I could hold it with 2 of the atoms here, okay, and look down from above as if I were a satellite taking a picture, then I could see the central atom, and I could just draw a straight line to the atom on the right, a straight line to the atom on the left, a straight line up, and a straight line down, and that's where the plus sign comes from. Right? But this is a tetrahedron. It is not flat. Okay? Just to illustrate that, if you make your tetrahedron and you end up with something flat, okay, possibly you end up with something that looks like a person making an X. So here I'm going to add a 5th atom, right? Just like somebody's head. Right. Okay. So here I have a little person, okay, standing in an X shape. This is not the shape of a tetrahedron. Okay. To get your tetrahedron, you would take your person and twist at the waist. Okay. Right? So imagine yourself standing with your feet wide and your arms up in the air like you're making an X, and then pivot at the waist so that you're facing over your right foot. Okay? And your arms are still up in the air. Okay? This is more what a tetrahedron is like. Okay? Your legs and your arms, or the legs and the arms of the person, right, are at right angles to each other. This molecule, this marshmallow is not twisting too well. There we go, that's a little better. Right? Okay. Right. So the tetrahedron is actually a very symmetric shape. There is not an upside to it. Okay? My marshmallow version, right, is a little lopsided and wonky, right? But the mass-produced version is nice and symmetric. Okay? So this is a tetrahedron. Yours isn't perfect either, that's okay. Now, the 3 shapes that I've shown you already, the central atom is fully bonded. Right? It has only atoms sticking out from its center. Its electrons have all been bonded. Now, these central atoms may be following the octet rule. They might not be following the octet rule, but they're fully bonded. Some molecules have unshared pairs of electrons on their central atoms. A trigonal pyramidal shape and a bent or angular shape come from the shape of a tetrahedron. So a tetrahedron normally has the atom in the center, and it has the 4 atoms around. So if one of the atoms is replaced by something different, here I'm going to use a piece of popcorn. I like using popcorn because it's light and it's airy, and that one just broke in half. So I'll use a bigger one. There we go. Okay. Takes up a lot of space, like electrons tend to. So now I don't have a tetrahedron anymore. I have a trigonal pyramidal molecule. It has a distinct top, where the popcorn is, representing an unshared pair of electrons, and it has 3 atoms around. It kind of makes a tripod. Right? If gravity weren't getting me down, then it could stand there nicely, right? Splays out a little bit, right? But still stays a little bumpy. It's not the same as a trigonal planar. Right? So a trigonal planar is everything is flat. A trigonal pyramidal has a bump to it. Now, the 3 bottom atoms are in the same plane, but the atom in the center is in a different plane than the 3 other atoms attached to it. In a trigonal planar shape, all 4 atoms are in the same plane. The central atom and the 3 atoms connected on the outside are all in the same plane. So this is a trigonal pyramidal. 1 unshared pair of electrons on the central atom and 3 other ones. The pair of electrons repels the electrons in the bonds of the other atom and pushes them a little closer. So instead of having the bond be 109 degrees, it's usually a little smaller than 109, maybe 107. There's another shape where a second atom has been replaced by an unshared pair. So I'll use another piece of popcorn. And this is called bent or angular. It's called bent or angular because the 3 atoms, represented here by the 3 molecules, are in the same plane and they just make an angle. The 2 pieces of popcorn are also, they are in the same plane as each other, but that plane is perpendicular to the plane of the 2 marshmallows that are representing atoms. This is one of the most important shapes in your life. This is the shape of a water molecule. And having a way to have a molecule that has imbalance, being able to slice it into uneven sides, creates polarity. And polarity is an important way for molecules to interact with each other. Molecules that are polar tend to interact with each other more than molecules that are nonpolar and are balanced. Okay? Just in a similar way to things that are magnetic, magnets will interact with each other more than things that aren't magnets. Okay. All right, so here are our shapes. Let's review. We have a linear shape. There's 1 atom in the center and 2 on the outside. They all line up in a row at 180 degrees. We have a trigonal planar shape. It's a very flat shape. There's 1 atom in the center and 3 atoms around the outside. If you trace the outside, you get a triangle, and the interior angles, the angle between any 2 atoms should be 120 degrees. The other shape is a tetrahedron, okay, where the central atom is fully bonded to 4 other atoms. And we have a trigonal pyramidal, right, which is a bumpy triangle, and we have a bent or an angular molecule. Thank you for watching the video. Have a nice day.